Hello, everybody, and welcome to PyCon Sweden 2021. This is the software track, and this is the third presentation on the second day. My name is Erasmus, and I will be the moderator for this session. We have Igor Mosyagin, who will present to us today. He is a data engineer at Klarna and has done a double PhD in theoretical physics and material science. He will present to us a talk called Self-Tracking and Self-Improving Using Your Habits with PyCon Ecosystem and Low-Code Tools. Welcome, Igor. The stage is yours.
Yeah, thanks. Thanks for the introduction. Yes. Shall I just start and run?
Yes.
Cool. Yeah. So my talk is going to be a bit about using Python to help know yourself better and tools that you can use to build all this pipeline of data collection. If I were to title this talk, I would probably give it a much shorter title, something like this. And we will cover what these letters mean, but you probably could guess that Py stands for Python. And Rasmus did a good introduction, but I'll just reiterate that I right now work as engineer at Klarna. I used to do science, and then I went to industry. But this way of thinking about problems when you try to read some papers, collect some data, and do some other things sort of deformed my worldview. And it left some sort of an imprint on me. There have been a few times in my life, a few is an understatement, when I felt like I'm just very lazy and I can't really do things that I want to do. So when I felt that, at some point I turned into the literature, read a few books, and this talk is sort of result of thinking about this and trying to implement some sort of things about that. When I was a student in my first or second year, I kept a time tracking journal with writing what I do every 3 minutes, and I managed to keep it for 2 years. It was a very stupid idea. Never do that, and I'll cover why in one of the parts of my talk. But in general, you shouldn't start just collecting all the data. You need to be very specific on what do you actually want to collect and what you will be able to analyze later. I also am a huge fan of octopus as a species and enjoy talking about quantum mechanics. So if you have anything to talk about that and just looking for someone to discuss some science about that, please reach out. Couple of things. I will be referring to books and some resources online and stuff, and I'll provide a link in the end of the talk to where I collected all the resources, so you don't need to distract yourself to Googling what I'm talking about. There will be plenty of time to distract yourself later. And this talk is about my own experience, so I will talk about things that apply to me. The sample size is just me, n equals to 1, and the company I work for doesn't track employees in the way I track myself. So it's a very separate thing. I talk about my own experience. I'm talking for myself, not about my employer. So don't extrapolate there, so to say. So what is the QS part? QS stands for quantified self, which is an approach that appeared in the 70s. And the idea is that, in the 70s, if you imagine someone trying to collect the data, it would be some probably nerdy type of guy, probably a white guy with a lot of weird devices on him that will try to collect the data, looking silly and stuff like that. So it was a quantometric self-tracking with a wearable devices, where devices were quite big. It's not like now we have these small watches or rings that collect everything. And it built a few ideas. And nowadays, some people talk about programming self, where you use the data to go further and try to make more suggestions on what should you do, how you should treat yourself, and what you should think about using the data you collect. Often the whole community of quantified self people gets mixed together with biohackers, the guys who experiment with some weird drugs or collecting your blood tests every few weeks. I don't think that's a really reasonable thing to do. I will focus only on the things that you can do with like your pure thinking and Python and maybe habits and stuff like that. But anyway, there is a set of basic principles that applies whatever you use. Even if you've been doing that in the 70s, you would probably apply the same idea or algorithm. And we will cover that. But the main thing I'd like to point out right now that it's very important to pick what you're trying to measure. When you're choosing the metrics you try to measure, and it's very easy to become this sort of data fetishist when you collect just everything and don't even think what you're trying to do with the data. I find myself that this approach is very bad and unusable. So think what you want to achieve in the end, and then start going backwards to see what would be the possible metric you want to achieve. So the main quantified self algorithm looks like this. First, you start with a problem or problem space you'd like to explore. Then you pick the metric we would like to use to measure this problem or something, and you collect the baseline data. This is a very important step. You don't really start changing something. You just first try to estimate what's your like base level. For maybe a couple of weeks, you just collect the data that you're trying to make your decision with. Then you change something, probably something very small, like you try to keep the environment the same, but aside from that one particular thing that you will change. Then you collect the same data using the same metric for more time, like a couple of more weeks. And then you make a conclusion whether this change worth it or not. Would you like to keep it? And then you go back to choosing another problem and repeat it how much times you want. So, for example, let's say, sorry for that bit of Russian here. You choose a problem like, hey, Google, how do I sleep? You realize that a lot of people talk that this blackout curtains is a nice thing. But before going there, you just try to keep track of what time you wake up when you leave in the bed. So then you collect the baseline. For example, here it says that you for 2 weeks, you track it in saved messages, which is a function in a messenger I use, the Telegram. So basically, my phone is always nearby, even when I'm sleeping. I know it's bad. I'm trying to change it, but I can't. So I always have this, and I can easily reach out and just check what time is it, write it down, say like, okay, I now woke up. Then you can install the blackout curtains, collect the data for 2 weeks more, and then you realize, well, you sleep better. Like you didn't track that, but you just feel that you sleep better. But you keep getting up later. So maybe it's not the solution for you. Maybe you need to go back to square one and then like track how sleepy you are. And that would be your estimation of whether or not you should keep this change. Or maybe you should like ditch the pillow and then try sleeping and see if you would still feel the same way, but maybe you will wake up easier because the bed would be not so comfortable. So overall, the flow is like this. You pick the problem, pick the metric, take a baseline, change something, collect new data, decide if you want to keep the change, and then take the new problem. And that's what was missing when I was trying to do the trick with taking my time to track what I was doing, because I didn't know what I'm trying to change. I was just collecting the data. More definitions that people use when they talk about that is that you need a cue, which is something that will sort of trigger your response to do something. The habit itself is a very tricky thing because, for example, you run for 2 years every day, and then you stop running. Would you say that you broke your habit? Did you have your habit before that? So all those people who say that you need to do something for X days, and then you will build a habit, probably have a very weird view on what a habit is, so you need to decide for yourself. But usually we tend to speak that habit is something that you do so automatically that you don't think about it. More definitions about that are in the book called Atomic Habits. But the other thing that's important is that you try, when you have the habits, you try to create rules that will help you stack the habits on top of each other. And then you use some sort of a commitment device, which can be a Python script or actually something that forces you to do something that you want to do. Like you burn your ships so you can't return, so you have to win the war, or you will lose respect. There's also a thing called cognitive load, which is amount of layers in your system, or rather like complexity of the system you built, that will give you the resulting point. So if you need to do a lot of steps to enter the data point, it will probably be very hard for you to keep that up. And another thing that you need to think when you develop such systems is that you want to think about the experience when you actually lose the track. For example, if you have an app that like congratulates you for each day when you meditate, once you meditate for like 100 of days, it will show a really nice badge. But when you skip one day, it will like show you 0, and that would demotivate you. And this is very this is a trick you need to keep in mind when you look at such solutions. To read more about this, there's a few books. I will mention that there's a nice blog of a Bminder service, which is a bit nerdy way to track your time. And the book Atomic Habits is a very nice one. Other books I will put in the link that I will provide in the end. How Python comes to that? Well, it lowers the cognitive load because you can automate a few steps. It helps you to process the trigger, and it ultimately helps you, hopefully, to build the habit to make it automatic, easy, and simple. Why use Python for that? Well, we all know that Python is the best language for anything. So gluing together a few systems using an API or building a pipeline is anything. And we're at the Python conference, so it's natural that I'm talking about Python and how to use it. I will proceed to look at a few cases and provide some advice on how would I approach that, and from my experience, how to use it. I use this app called Dailyo, which is a day mood tracker. You just take a very small input, which is like an estimation of how you feel. You can put some tags, and then afterwards it builds some statistics for you. The problem with that is that the author of the app decides what data I want to see and how it can be collected. Usually this sort of app doesn't have any API, so you can't really, use build a service that will track the data automatically when you press the button somewhere else on the kitchen, for example, every morning. But it provides a way for you to export the data. And usually it's some table-like format. Dailyo provides CSV. It used to have it only in paid version. I think nowadays it's in free version as well. And why would you want it? Because, well, you want to plot the data yourself. You want to do some processing that app doesn't offer, or it may be some very weird way to process stuff. And you want to play with the data that you know what was the source of the data. And you is the source, is like most reputable source for you. So for example, here I plot autocorrelation plot for my data. Autocorrelation plot is a tricky way to understand, is there any correlation of the data points from the data points before? And it's a very nerdy thing. It's unlikely that it would ever be introduced in the app, but it's there, and I can now make a suggestion about this. And yeah. So a bit about the code. Of course, you can say that this particular place here, where I convert my mood to numbers, can be rewritten differently, like something like that. And the good part about project like that it absolutely doesn't matter. Because you write the code for yourself, you want to be comfortable with the code you write. And if you have problem writing like code that wouldn't pass the linters that are set up in your company, I would really suggest you to read this book, Exercise in Programming Style, where there's 30 ways to solve the same word count problem in Python using different approach and different styles. It sort of unlocks you in a sense that now you don't really care how you name your variables, as long as you're comfortable with that, and as long as you decide that this way, this approach that I will use here would be maybe not really scalable, but it will do the thing. And this book enabled me to write like code that just does the job without really thinking of how beautiful it is. Because before that, I was really stressful about that, and that was blocking me from writing stuff for myself that would solve my problems. Second case is reminders. When most of the currently used messengers have this way to remind you about something, or you can use a reminder in a calendar, I found that it never works for me. And usually it's better if someone messages me. And that someone could be a program or a bot, which just can be set up in a cron, a simple script that will just send the message. And the fact that that message was sent by someone probably will raise my attention, and then I will react to that. There is a service called Zapier, which allows you to send different messages to different services, but it won't allow you to send just unrestricted HTTP requests on a free plan. It will require you to pay for that. So in general, I would say that renting a server with DigitalOcean or similar provider would be cheaper, because then you can host anything you like there and collect the data there, and would be independent of the policies of other services. And just in case of Telegram, it's really these 50 lines of code that will send you the message, and you don't really need anything more. It's just one dependency on requests, and you just send the message there, and you don't really need to get into details of how the API works. It's just a very simple snippet that will just do the trick. So it's nice, refreshing way to write code when you know that it's a very simple change. For reminders, again, you can go further and say that if you don't like requests, take another library. If you want to try Asyncio, take that. If you don't want to use cron, you can try to use Airflow. You can try to use this N8N thing that is just basically a visual coding tool that you will need to keep in Docker, but that doesn't really relate to Python. Or you can use tools like Integromat that has integrations with Telegram built in, and like I think Discord is as well supported. Keep in mind that when you use these services, it ultimately means that you will have to pay some technical debt, or that debt will need to be repaid later. But again, that moment might never come, because you build stuff for yourself and you use it only for you. So that might be okay to use that. The one thing that usually doesn't really come to mind if you just live in a cave, so is that reminders as triggers can be triggered not only by datetime, but also by geolocation, which can be not a GPS, but some sort of triangulation of a signal, for example, from the nearby cell towers, which uses a little amount of battery. And there are apps on Android, for example, the app called Tracker, that allows you to set that when I get here, please send HTTP request with this payload somewhere, and that will work. The other thing is, like, you can scan a QR code that will do the same thing, or there could be like a chat message or Internet of Things devices that will like trigger a particular thing when you do put it on a particular site. I would say that the main empirical rule of self-tracking is that it's better to motivate yourself through reward than through punishment. So if you have something tasty, it's better than if you flog yourself that you don't do something. And you need to think about that when you do all these triggers, that it shouldn't really punish you. So in sense of reminders, that probably means that the communication should be more nicer to you. I will talk about that a bit later. When you collect the metrics, basically anything you do with quantified self usually falls into this category. So you have some data, you collect it, you visualize. If you go locally, you can use SQLite. But let's take that in more details. When you start searching for something, it turns out that there's a lot of people who in academia who actually know how to measure something, and you can just go to the internet with like asking, I don't know, Stanford scale for awareness or something. That would help you to get some sort of tricks how you can convert your current level of awareness to a number that you can plot. The catch here is that you still need the data, so you need to collect it. This is example a sleepiness scale for Stanford. So you can use that, for example, as a source to track how sleepy you are during the day to find your optimal times. And when you write that, it would be simple bot message sending you how it's going. You get the response, you track it into SQLite, and then at some point when you get the data, you just plot it and analyze it. And the thing is here that this data input should be as automatic as possible. Sometimes it's impossible to do that, but if you use the chatbot, the interface is so natural that even just that simple thing is kind of easy to do. I would also just don't use Matplotlib for visualization. Try to use something else just to destroy the monopoly of Matplotlib, so to say. For example, here is the bot or case I was using when I wrote this. I started going to the gym, I started tracking my exercises. And I didn't like any apps that I found because they were very slow. And I wanted to have my graphs that I built myself. I didn't want to wait until the author of the app will implement them. So I started tracking it in the private communication with my bot. And then I realized that I don't really like writing JSON. I just want to write simple messages, and then I will need to parse them. So when I get the message, I first start with stripping it and splitting it for lines. And the part with the date is easy. I just take my favorite datetime library, parse that. That was fun. The part here, when I need to track the numbers, was a little bit more tricky. So I had to process it a bit. So I take the volumes, count this, process the lines, and so on. And then I had to write a helper function that will translate all these values to something like a number, like how much weight in total I did for a particular exercise. So my first attempt was really easy. I would never write this code in production, but since it's my way of doing things, I can have things like eval that will just put all the parentheses, change spaces to pluses, and just basically translate it to an arithmetic expression. And it would work fine for a while, but then I get a message like here where I actually understand that I write it differently. And I was like, oh, well, I would just need to change it somehow. And just a couple of more hacking around, very weird names, very bad code technically, but it does the thing, it works, so it's good for me, and I'm happy with this result. So I would say that in generally being happy with your script is more important than doing something that other people tell you how to write your code. For the metric collection, you can start with simple SQLite, but ultimately you would probably want to go further, and there are a few ways to do that. I usually use one of those three guys, well, technically one of two. I never got around to actually use the third one for anything real. The first one is Google Sheets. It's nice because you know how Sheets works. You can show it to someone, that person would know that, but there is a terrible downside that it has a very bad API that's really hard to use for me. That Airtable is basically so that created its own version of Google Sheets. It's a nicer API. It looks like a normal database, but it's very inconvenient for people who don't know what a database is. So when you share your data with someone else, you might get in trouble and you will have to explain how that works. This guy here is called NocoDB, I think, and it's open source. It has a great documentation, but it requires hosting, so it's like the main downside of it. But overall, this is basically a clone of Airtable that can be used for your project. For visualization, I really recommend you trying the lib called Altair. It's much more natural to write graphs in that than write graphs in Matplotlib, though it's not really a big of achievement. And for dashboards, try Streamlit. It's a very simple wrapper that sort of gives you a nice dashboard that can be used with Altair or a few other tools. Streamlit itself, very easy to pack in Docker, and then you will just like build it and provide the dashboard code, which is very simple statements to read, and you can add like markdown like things there. And it goes well with pandas itself. So yeah. When you have more than one metric to collect, you can start to... It's very easy to shoot yourself in the foot when you have separate services and they start to connect with each other. You would either hack an API, or you would introduce some big monster like Django DRF into your small little script of 50, 70 lines, and that would just be horrible. So you would end up losing motivation. I would suggest go a bit further and do an architecture overkill by using some sort of thing called Eventbus, which is a solution that you would have like a pipeline of that stores messages. You will send messages there, and then other services will collect that. A really nice one is NSQ. It has a built-in way to send HTTP data, and it has a few libraries, officially supported libraries, to read data from that. And the Python one is very nice and easily supported. So to not shoot yourself in the foot and don't get under the bus. Try to avoid like standard ideas of Eventbus solutions, like use JSON everywhere, don't use protobuf, because you would really want to read what you write. Use some leaps for serialization, don't do it yourself, and host this bus somewhere stable. So probably hosting it on Raspberry Pi wouldn't, in your apartment wouldn't work, but hosting it on VPS would be perfectly fine. So a few advice. Where to host stuff? There are three basic options. First of all, you can try actually use the Raspberry Pi you bought a few years ago. It's cheap. It finally will get some usage, but it's very hard to monitor and have it properly uptime. So when it falls, you probably would have to physically get there to restart it or something. If you try to go with hosted solutions, you will practice deployment, but if you never did that, it's a bit of steep curve there, so you will have to learn how to do that. Tools like Heroku or Netlify are easy to use and easy to expand, but they cost money, and the more you use it, the more they cost, but you can get around with very small solutions for that. Regarding the code quality, please be kind to yourself. I managed to fall into this trap a lot when I was not writing code for me because it was not good enough. But once I unlocked it, I started writing like proper code, and just getting stuff done is more important here than just being ideally PEP 8 compliant. Since it's a pet project, try use new technologies, and ideally every time you touch the code, end up with something that will improve the results noticeably. A few leaps that I use for all of my projects is Pendulum, Reach, and the leap called K-Ring. Pendulum is just a tool that I learned when I was working with Airflow. That really nice way to process datetime stuff. For me, it was much more convenient than using the datetime library, because it has a few nice ways to parse it and translate it to different languages for relative timestamps, and easy way to add the time deltas. Oops, sorry for Russian again. The Reach is a library for terminal interfaces that will allow you to write better terminal tools that will be colorful, nicer, and it even has the progress bars. The K-Ring would save you from exposing your secrets, and it's just a couple of lines in your code. Then you will be sure to never publish your secrets in a repository somewhere. And the last advice is that please make your code with some sort of a bite, I would say. So all the log messages should be not boring. Otherwise, you will end up ignoring them because they would be annoying. There is an easy way to do it. You will just replace boring things with more aggressive ones, and then you would add like a few lines that will randomize these values. And then you will sort of have an emotional reaction to that. which is a way for you to feel better about these tools that you write yourself. Given some bot personality, it's easy if you use the site RoboHash, because you can sort of enter the name and it will generate a few variants of an avatar that you will use for your project. It's silly, but it helps you to distinguish different projects between them. A couple of examples of projects. First one is, is a pinger that will sort of help you to reflect on yourself. It will ping you daily and just randomly prompt you what you want to reflect on, and then you use Heroku to collect the responses. The other one is like a tracker for the sleepiness self-scare, which is storing the results in Airtable, then analyzing it, and then once you have the average, it can ping you back and ask, oh, okay, right now you probably feel at this level. Is it true or not? And then you can adjust it and see how things change. Oops, sorry for rushing again. The third one is like a helper for you to track your decisions. For example, when you write something down, you say that I decided to do that because of that, and then it will follow up you like a couple of weeks later to test was it true or not, and then you will hopefully make better decisions. So in conclusions, bots are awesome, Python awesome, Quantify itself is great, be kind to yourself, give some character to your code, and write code to learn yourself. It's fun, it's a nice way to exercise your skills. A few books to get some ideas. I'll mention them in the link, but the nice one is this one, because it tells you how to use Streamlit, and these two are quite similar. The left one is a bit easier to read. This one is written by someone who's really crazy. So that's about it. Let's wrap up and go to Q&A. Thank you.
Thank you so much, Igor. So we have a question here. Besides your mood, what are you tracking?
Yeah, so at the moment I'm tracking the time I spent on doing some currently I'm tracking the time I spent in meetings and the time I spent debugging the code. I have this device that allows you to track what you're doing depending on which side it lays on. And I find it's really like driving me nuts sometimes. So I think I will change that, because it like I feel anxious every time I'm in the meeting and I haven't turned it on the proper side. So it's annoying. I track my gym exercises, volumes, and I see how I progress. Sometimes I track my food. I fell off a while ago, but that's also some sort of similar logic that I shown in the gym tracker. And a few times per year, I track my sleepiness scale using basically similar approach, just to see if, I don't know, if for example, I moved to another place, there's more light, or I spend more time inside. So how sleepy I am during the day is very important for me sometimes.
Have you felt that what was the purpose then of tracking the meeting and debugging? Was it to like reduce the meeting times and reduce debugging time, or what was the purpose?
It was just for me to feel that there's, like, for example, often I feel really shitty about my day when I realize that I haven't really wrote enough code. And then I can look at my tracker and see that, well, I had like 5 hours of meetings, so it's not a surprise that I haven't written much. So that sort of balances it, normalizes my experience of the day.
Okay, I guess sometimes like, what do you feel about, like, sometimes if you, for example, measure sleep, and you see that, okay, my normal sleep time should be from 10 p.m. to something, and then you realize, oh, I haven't fallen asleep yet, and it's 11 p.m. That can make you quite stressful. I mean, you mentioned it earlier that you got a bit stressed, perhaps, using that tool. So I guess measuring some things can also, like, influence.
Yeah, that's
as
true.
well.
But I tried not to make much about that. That took a lot of work for like letting go of this and not making your life harder because you tracked something is a very like hard skill to master. I don't think I mastered it yet, but it's definitely getting better.
We have several people saying it was a great talk and fun and interesting. Tobias,
thanks.
Martino, great talk. Andre as well. And then we have Helio who says that RoboHash is a cool project. So
Yeah,
that's a good tip.
I use it for all my bots. I think currently I have like 5 of them, and they all have a different use. And RoboHash also has the way to generate kittens, I think. So not only robots.
And Andre mentions that doing full squats, bench press, and deadlifts at the same day might kill you.
Yeah, but if you actually look at the numbers, they're quite low. So, but I do hate stairs after days like that. True.
Thank you very much, Igor. You have given us a lot of tips on tools and how to measure stuff to improve ourselves.
Thank you for having me.
Thank you so much. See you after lunch, everybody.
Yep.